I'll go ahead and introduce myself. My name is Kevin Clarke, and I'm the digital projects programmer at Princeton University. And what might be talking about once it opens up is an expert in how we use the digital collections.
Thanks.
And we are using this is not what our talk is about, but we are using a data XSLT database, which I wasn't going to say today until Andrew kindly pointed out which one we were using. but that isn't necessarily, you don't have to use XQuery with the data XSLT database. So in just a few more minutes, that starts.
Function F4 might help.
It's got to get through first.
Yeah.
Shadow puppets, anyone?
Oh, it's booting.
I can dance. I knew that would make Kevin go faster.
No, please.
You want an interpretation of that dancing?
There we go. Thanks for your patience. So as I said, my name is Kevin Clarke. I'm the digital project programmer at Princeton University. We've been using XQuery for about 2 years now. And so I'm going to talk a little bit about that, about XQuery in general and about how we're using it. So those are the sort of two focuses. And even when I'm talking about XQuery, I'll give you hints as to what we've learned along the way, because it has been a learning process, and we've done some things differently as our digital collections have grown. So what is XQuery? It seems pretty simple. XQuery is an XML query language. It doesn't sound like that would be that difficult to understand. It comes from the SGML world. If you look at the working group for the XQuery spec at W3C, you see a lot of IBM, Oracle, Microsoft, a lot of mainstay relational database folks who have been developing this standard. One thing that might be confusing about that is that the XML query language doesn't include two things, which many people may think of as when they think of query languages. For instance, it doesn't include full-text searching, and it doesn't include some sort of update. So these are things which aren't a part of the XQuery spec. They are things which W3C is working on, and there are specifications for each of these that are making their way through the process. But if you try to use XQuery as we initially did when we started working with our collections as your full-text engine, there's some problems associated with that. Now, this isn't to say that a lot of the database vendors or XQuery engines that they haven't gone ahead and implemented these things on their own. They do. They provide a lot of full-text extensions for full-text searching, and also there was an update extension which has been basically built into the XQuery language by several XQuery engines or database vendors. They're really one of the main strengths of XQuery, or at least as what we found, is that it integrates data from a lot of different sources. So while you may think of SQL as coming basically from the database world and dealing with databases, XQuery is really intended to work at the XML level, so it's intended to work at a little higher level than SQL. So whether you're getting your XML from a relational database, or from a native XML database, or from files in the file system, or even web services, XQuery is a nice language that you can use to work with these different resources coming out of XML. And I completely agree with what our last presenter said, that there are different strengths and weaknesses to each of these. So you don't necessarily want to use a native XML database for everything. Some things you want to use a relational database for. Some things you might just need a file system and a good indexing system. And XQuery can work with all these sources. All XQuery cares about is that you're giving it XML. And once it has the XML, it's very happy. And this is actually one of the reasons why we were very interested in the Solar workshop yesterday, is because right now we're doing all of our full text searching in with sync, and the idea of being able to do this through a web service and just working with the XML and integrating it into our XQuery environment is very enticing to us. So XQuery, as I said, gives you the ability to focus on the data rather than the databases or where it's coming from. And it's worth noting that even though you can say XQuery is a programming language, it's not a full-fledged programming language. There are a lot of things that it doesn't do at this point. There is some work underway with a standard called XQuery P, which is to add some of these additional features into the XQuery language. And that's not, I don't think that's something that's officially being channeled through W3C at this point, but I'd be very surprised if these types of features didn't work their way into the language eventually. And so XQuery is something that's evolving, and as Andrew said earlier, the optimizations that have been written for XQuery aren't as, it hasn't been around as long as relational databases, so they're still working on the optimizations. But it is very useful, and it's very convenient for a number of reasons. So I wanted to start just by showing you a few XQuery examples, and just to give you a sense of what the language is like, and then also talk about how we're actually using it. So it's a functional language. It's built entirely on expressions, so there are no print statements, put statements, system out print line statements. So what you see there, the hello world is your obligatory hello world example. You give that to an XQuery engine, and it's going to spit out hello world. The 1 plus 1 will give you a 2 when you give it to an XQuery engine. So those are just very simple XQueries. One of the reasons that you might want to use XQuery for development is if you're working with a lot of XML information already, and you already have your mind in the XML mindset. XQuery, because it's written for XML, uses native XML types, and it also uses XPath. So in this example function here, and this isn't necessarily something you want to do because you don't need a function to wrap around an XPath expression. But just as an illustration, in this example here, we've defined a function, and we can pass in values. We can define them as XS string. And so the data types that are being used here are the same data types as the W3C schemas data types. So there are some very primitive data types, strings, positive integers, dates, that sort of thing. You can use custom data types. So as you know, with RelaxNG or W3C schema, you can define custom data types. Not all the XQuery engines support these custom data types at this time. So, and most of the open source ones, I think, don't. So if you wanted to get really fancy and start using some custom data types, it's something that wouldn't be supported by most of the open source XQuery engines. You can see here that the native XML types like element, document node, item, and attribute, and just plain node are all things which are supported within XQuery. And these are just native types of XQuery because this is what it does. It works with XML data. So you see, and you can also see from the function here, this is an example of a function that returns an element, and an element sequence, which is another native type for XQuery. The sequences use the same notations as ETDs. So this particular function will return an element sequence with 0 or more occurrences. You can say one or more occurrences. You can say 0 or 1 occurrences, and indicate what sort of what you should expect to come back out of your functions. As I also said, XQuery uses XPath, and XPath, as most of you probably already know, is a very powerful way to express location and matches within a hierarchical structure. So in this example here, just passing our strings through, we can see that we're matching in our data field tags with our string values that are passed into our function, and the same thing with our parent here. One of the advantages of, or some people might think of it as an advantage of XQuery, is that it can either be strongly typed, like in the last example that you saw, where I actually said that these are strings that I'm passing in and that I want to return a sequence of records from it, or it can be very loosely typed. And here's an example of that very same function without all the typing incorporated into it. So that if you don't want to have to say this needs to be a string that gets passed in, you can do that, and you don't have to worry about what gets returned. We've actually, in most of the XQueries that we've written so far, we've been using the loosely typed method here, and it makes it easy. For sometimes if you're requiring an element to be returned from something, it means an extra element construction. Whereas if you're loosely typing it, and we just return an empty string instead for no response, then we don't have to worry about that as the extra element construction. But so the same example here with this, with it being loosely typed. It's worth mentioning that Elsevier has done some work with XQuery, and they've developed a very useful set of guidelines for documenting your XQueries, so that you can basically have Java docs-like documentation that's built into your XQueries that can be used to generate HTML documentation on the fly. And they've also done some work into coming up with some code conventions for XQuery. And as we look through a lot of our 2 years worth of XQuery, we're starting to realize that these would be valuable and to help maintain, this large amount of code that we developed. So we are starting, as we rewrite things, we're starting to rewrite them to be a little more strongly typed and also to use this documentation and code conventions, which I know there are many different opinions on whether those things are good or not, but there are things that I think are working pretty well for us. XQueries also support, because they come from the SQL world, also support flower expressions. And here's just a simple example of what it would look like in XQuery. You wouldn't necessarily want to do this. Everything that you could express in this flower expression except for the order by is probably something you could do in an XPath as well. And for many of the XQuery implementations, the XPaths are evaluated much more quickly than the flower expressions. The flower expressions are much more expensive. But just for illustration purposes here, you can see in our example flower. And you will notice too with the XQuery, the elements are actual types. So regardless of whether you say that your results are an element in markup, the way that I have it here, or you can actually define an element in the code, in the XQuery part of the code that represents the same thing. So you can have code within elements and then also elements within the code sections there. As you see in return statements, returning the subfield, the text value of the subfield. Since it is a developing language and there are a lot of things that it can't do right now, they provided a very convenient way for people who are working with XQuery and who want to use it for a lot of their systems to give it additional functionality, and that's to provide an extension mechanism into the XQuery spec. So that for instance, if we need to do something which isn't supported by XQuery, for instance, posting to a Solr web service, we can do that by writing a simple extension class. And the XQuery engine that we use is Java-based, so all of our extension classes are Java-based. Most of the ones that I've looked at are Java-based, but I know there are a few XQuery engines out there that are written in C and other languages, so I'm not sure whether they're extensions, whether you can write extensions in C or the Rubies or Pythons or the other languages. But Java is very convenient because it uses Java reflection to load the Java class and then to execute a static method in the class. So here in this example, our first example, that file is 2XML. You can give it a directory within your file system and then a pattern of file that you want it to match. So if we wanted to match all of our EAD documents, we gave it a regular expression. It would match our EAD document names. Then this would return an XML representation of our file system, which we can then process through our XQuery, looking for all the turning that into a document, and looking for all the paths in there, and work through each of the EADs within that file, and there's an EAD to Solr module which we've written, which will take an EAD document and generate the XML that Solr expects to get in order to add it to its index. And so it'll take each EAD document here, generate that Solr document, and then we have an extension which is just basically an implementation of the URL connection classes in Java, which posts that document to our Solr web service, and then the comment there, following it up with another one with the commit. So here's another example where you can see the commit, which is XML markup there, is treated just the same as the element, which goes in as the Solr variable here. So it doesn't really make that distinction. It's working with XML from the very beginning. So a little bit about how we're using it. I started working at Princeton in 2005, and when I arrived, they said we have this XML database and we have this Fedora instance, and we would like to have a digital collection site online within about a month or two. And so we started working on this, and actually most of the time, after looking at the two issues, we ended up going with the data XML database and using XQuery, though we weren't thinking about using XQuery at the time. We were thinking we were going to do most of this in Java. But we ended up choosing that over the Fedora just because we felt like it gave us a little more freedom. And Mark Blake has a really interesting blog where he refers to this as outer space, where he talks about all the great things about Fedora, but then contrasts it with the Martini model, which is more of the XML files on the file system, and giving you a lot of freedom to do what you want to do. And what we saw in our native XML database was sort of the same thing. It wasn't files on the file system, but it was at a much granular level, having access to the data itself. And APIs are great, and we love APIs, but sometimes they can get in the way of what you want to do too. But the downside of that, of course, is that we don't have a lot of the tools built into our system. We're developing tools as we go, as we need a lot of tools that would come out of the box, more or less, with Fedora or more established repository system. So we've been developing for 2 years now, and our use of as I said initially, we started off doing this in Java, and just started looking at XQuery because it was something that the database supported, and it was just so easy and so much quicker to develop a system using XQuery that we said, oh, this is great, let's use this instead, and put the Java stuff to sort of the back-end work. And so here's just a very general overview of our architecture. Right now, all of those happy faces are the catalogers creating metadata. And we're a mets-based system, so we actually store the mets in our database. And one of the decisions that we made early on that we regret now is that we actually ingest all of our descriptive metadata into the mets records before as we're storing it into the database, which is great. You know, it makes writing the queries easier because you have all that information there, and the database doesn't care about how large the XML files are. But the downside is when you actually want to maintain that data, you then have to write something that will let you operate on the descriptive at the level of the descriptive metadata. So because we're had a few programmers and a lot of projects, we haven't gotten around to a really good descriptive editor yet, so we pull things onto a file system, and we have people editing XML at this point on the file system. And then there's an ingest process that pulls them in a batch mode into the database. And that's not necessarily the ideal situation, or where we'd like to be a year from now, but it's how we've evolved up to this point. So we have a very thin layer of Java servlets that sit on top of our database, and on top of our Lucene instance, and we also use JP2 for our image server. And the Java servlets from an XQuery's perspective just deal with the database connections, they do some session pooling, and they sort of manage the overall environment, but they don't actually do any of the logic that's performed on the site. All the logic is done by the XQueries. So we're primarily an image-based site. We do have some search, but we have browsing as our main mode of navigation at this point. And so the XQueries are working with the METS records and the structure that's incorporated in the METS records in order to generate our site. And what we spit out depends on, is different in a few situations. We don't really have a standard form I was interested in. We aren't using, there is a full text with XQuery, and we weren't particularly happy with our full text provided by our native XML database. So we implemented our own Lucene, standalone Lucene thing, which connects directly, the HTML connects directly to Lucene, but then what we get back from Lucene are the paged results, so first 20 IDs or whatever of our records, and this goes then back to our XQueries, or the XQueries manipulate the METs, pull out the records that we want, and display them on the site. And the JP2 is the same thing. It's a Java API for our JP2 server, so there's unless we did a web service or wrapped around that, we really couldn't use the XQueries with the JP2 server. So to-dos and redos. We first tried full text, thinking this XQuery is a full text, query language, and it's not. So we had to look around and find other things we'd like to do. The idea of Solar and having search as a web service is really enticing, and would fit really nicely in with our current architecture. So we're looking at that for a variety of projects. We do our digital collection include projects that we're digitizing from rare book special collections. It also includes EADs, and there's a CPANDA project, which has been incorporated into the digital collections architecture now, which are all based on our XQuery-based system. One of the things that we would do the second time around, and I think to be fair to us, this was in part because the spec has been changing. Since it has just become an official spec in January, things have changed over the 2 years that we've been working with XQuery. And when we first started, the XQuery modules, the ability to modularize your XQueries, wasn't supported by our XQuery engine. So we did pretty well. We have a lot of small XQueries, but then we have one massive, huge XQuery, which would be much better refactored into smaller modules, which could be then reused and just easier to maintain. So that's something that we're looking at. We're looking at a site that's redesigned basically for usability purposes, and it's a good time to look at our net structure and breaking those out into descriptive records, and also looking at redoing some of the way our XQueries have been created. And so things we like about XQuery, as I said before, sort of the outer space idea, having a very granular view of the data, being able to work with the data directly. Unabashedly an XML fan, so having a programming language that lets me work with the XML directly is a great thing in my eyes. It makes it very easy, and I don't have to shift mindsets. And it's also great, XQuery seems to be picking up a lot of steam. It's been around for a long time, but it hasn't really become an official standard until this year. And it seems to be picking up a lot of steam in terms of interest and implementations as well. So that's something that it's interesting to look forward to. And it'll be interesting to see what happens to the update and the full text specifications too. So that's the end of my presentation, and I'll be glad to take questions.
Did you look at Sparkle at all compared to XQuery?
We didn't look at it seriously. I mean, I'm aware of it, but we were. I wouldn't say. I hate to say this from this audience, but I wouldn't say I'm a huge RDF fan. so XQuery was more along the lines of what we were interested in.